Now, without further delay, it's my pleasure to introduce our next speaker, Dan Schellhammer. Today, he will be discussing cold-in-place recycling. Please join me in welcoming Dan to the stage.
Appreciate it. Thank you. Everybody hear me okay? Sounds good. All right, awesome. Excited about the opportunity to talk to you guys about cold-in-place recycling today. Just kind of wonder by a show of hands, how many people here have actually been on a job where cold-in-place recycling has been happening? I don't see many hands, right? So the process, honestly, in my opinion, is drastically underutilized in the asphalt rehabilitation space. And hopefully after my 25 minutes here today, you got a little more information, maybe be encouraged to try it. But with that, go ahead and get started. So when we talk about asphalt recycling and pavement rehabilitation, the way we like to talk about it is that we think of the different treatments that are available or techniques as tools in a toolbox. And there are times when you take different tools out of a toolbox to make a repair, right? So if we need to drive home a nail into a board, can you get that work done with a screwdriver? I could, with my Neanderthal thinking, right? I could turn it upside down and take the handle and smash it on top of the nail head, probably get the meaty part of my hand all bloody in the process and make a mess, maybe bend the nail, but I could make it work, right? But it's really the wrong tool, right? And so when we're talking about pavement rehabilitation, utilizing the right tool in the right place, the right time is key to having a successful project. That's really applicable when it comes to cold-in-place recycling. And so in order to ensure you're utilizing the right tool at the right time, the right place, you should be able to say yes or check off each one of these things you see up there on the screen, right? You should save money versus what your alternative might be, right? You should save time. You should accelerate your construction process. You should give yourself a chance to really change your design process and how you look at that whole entire pavement layer system, right? When you're doing that. And through that, you should be able to extend the life of the pavement. You should make it last longer if you're utilizing the right thing. And this is when you compare it to the other options that are available to you. Ultimately, you want to reduce maintenance costs. And then, some folks care about this more than others, different circles I run in, but reducing carbon emissions and then recycling and reusing. When I think of the roads that we've recycled in the past, the cold-in-place recycling, when we see an old, tired, aged, oxidized asphalt pavement, I don't see that as a liability. If you're an owner, I would look at it as a resource that taxpayers have already paid for. The rock that's in that old asphalt, it's still there, it's still good. The asphalt that's there, still good. It just needs to be repurposed, right? So really, honestly, the last thing you should do is to tear it out or take it apart. If you can repurpose it, it's going to be a better investment, and you're utilizing the materials that you have there. And ultimately, it should lead to lower costs. So what are the benefits of cold-in-place recycling when you utilize it on the right road, at the right time, in the right place? You should see a reduction in pricing of 30 to 50%. That's the type of benefit you should be looking for. If you're not saving that kind of money, there's probably a different technique that would be better for you. The great thing about cold-in-place recycling is you're creating cold mix. Cold mix is really good at reducing or even eliminating reflective cracking in your asphalt pavement. I'll talk about kind of why it does that a little later. But whenever you can reduce reflective cracking, you're going to get a pavement that lasts longer, right? So that's why you want to do CIR. With reduced cracking, your maintenance costs go down. You have less cracks to fill, less water infiltration into your subgrade, into your base down below through those cracks, right? Make your pavement live a longer, better life. The CIR process on the right road, properly engineered, it'll last 25 years plus. We have some examples where it's lasted more than 40. It really just depends on how the condition of the road when we first started, right? And this is where you're applying it on the right road at the right time. We have done this on roads when it was the wrong project, it was the wrong time, the wrong pavement condition. They might last 8 years. So really, project selection is key to making cold-in-place recycling work for you. And then you should reduce construction-related carbon emissions by 50 to 90%. I know in the state of North Dakota, this is not a big deal, but in other states in the U.S. it is, like the state of Colorado. They're talking about carbon emissions all the time. State of Minnesota, legislatively, they have to start reporting CO2 emissions on their construction projects by 2028, right? And we're kind of scrambling. I'm from Lakeville, Minnesota, by the way. And the DOT and the paving associations, everybody's kind of scrambling to figure out how the heck we're going to do that, right? So I don't see that coming to North Dakota anytime soon, but folks around here are doing that. So let's get down to the cold place recycling process. So this is a multi-unit train. The process itself is we want to go out on an old, tired, oxidized road, right, of asphalt, and we want to basically repurpose that old asphalt. How are we going to do that? Well, we're going to cut that road up. We're going to pick it up a full lane width at a time with that mill at a depth of 3 to 4 inches. We're then going to crush and size that recycled asphalt down to whatever specified size it needs to be. Most of the time, it's 100% pass at 1.5 inches. Sometimes it's 100% pass at 1 inch. We can change up our approach with the equipment that we have to really meet any gradation specification that's out there. After we've recycled that asphalt and sized it, we add some oil to it. Might be an emulsion, might be foam. We make cold mix, and we put that cold mix in a windrow. Then we pick it up and pave it like you would normal hot mix job, right? With a pickup machine, modern paver, and you roll it out. So we generally get about 2 lane miles a day is our production goal when we're doing cold in place recycling, so we can move right on down the road. Now that can vary a bunch. What makes it vary the most is the hardness of the rock that's in the asphalt. If we're working in, I'll give you 2 examples from Minnesota. If we're working in the southwest part of the state where they have quartzite that they use in their asphalt, that stuff cuts hard. It is hard rock. It's really abrasive. We might only get 1.25 miles a day, sometimes just 1 mile if we're doing a 4-inch cut, right? We go to the eastern part of the state, though, along the Mississippi Valley there, where there's a lot of limestone. It's really soft. That stuff's easy to cut. It's not so hard. We might get 4 miles a day. I think our highest production day, we got 5.2 miles in 1 day with the process. Just depends on how hard it's going to cut. And what are we producing? We're producing cold mix, right? And a lot of folks that when you conceptualize, cold in place recycling, you come out to a job, you're going to see something that looks a lot like hot mix, honestly. So it's going to be black, it's smooth, it's paved in a similar fashion, right? But it's different. And so picture on the left there, that is a cold in place recycling job, where that lane on the left is lane to be recycled. The lane on the right has already been rolled out. It's completed. Right? So it looks black and smooth. Looks a lot like an HMA job. But the 2 materials are very different. And so when you're looking at cold mix, the picture on the right, you folks in the back, you probably can't see. It's hard to see. But that is uncompacted cold mix mat. And you can see if you go up the front here, it's a lot chunkier. It's a lot coarser than hot mix. So when we make cold mix, the percent voids that are in cold mix versus hot mix are about double. So we have a lot more free space and void space in it, right? Which is great because that helps prevent reflective cracking. What it's not great for, especially here in the upper Midwest, is making it through a winter, okay? If you had a cold mix mat that had been compacted, it was left out to elements in the winter and not surfaced with anything, you're gonna get water infiltration. It's gonna freeze and pop out and make a mess. It can't live on its own. So it always has to be surfaced with something. So that's why I say it's sensitive, right? It needs to be covered up. It needs a blanket over the top. There's lots of different ways that you can cover it up, though. We'll talk about that in a bit. It's gonna jump forward like 3 times now. There we go. So I just want to pull the parts of the train apart and tell you about what we're doing with each of them, with the construction process. So up front, you'll see a tanker. Most of the time it's a water tanker, sometimes it's an oil tanker. An oil tanker is basically feeding the surge bin at the back for making the cold mix, right? If it's water, we use water for several different things on the train. One, we use it for cooling our wearing parts, right? We have these carbide bits we use for crushing this asphalt. With a little bit of water, they last a lot longer. 2, we use it as a compaction aid when we're compacting our cold mix, right? We'll optimize the amount of water we should add, right, in the mix design process, then we need to add a little bit of water. And then 3, another reason that we use water is we use water as a dust suppressant to keep silica dust from getting silica dust exposing our employees to that type of issue, right, when we're crushing RAP or asphalt, right? We want to keep those small particles out of the air and keep our employees from breathing it in, or construction inspectors out in the grade or anybody else that might be driving by. And so the reason we call this work train work, right, is because the first 4 pieces of equipment I'm going to talk about, they're all interconnected with pintle hitches. They're all connected together. And so the next piece of equipment, that's the locomotive on our train, is our mill. So this is a big 12-foot wide mill. You can pick up the asphalt depth of 3 to 4 inches at a time. It just cuts 3 to 4 inches all day, every day. That's the only job it has, is to pick up that asphalt and get it back to the crushing plant to make cold mix. Now what's unique about this mill is that it does have a down cutting drum. Most mills have an up cutting drum. Up cutting drum is really efficient at getting old asphalt up off the road and up into a truck, right? A down cutting mill head actually helps you with sizing. So we get additional crushing with a down cutting head. It helps us get better gradations. We use this piece of equipment. Now I did talk about, carbon reduction and carbon savings. This big mill is about 1,050 horsepower, and it's very thirsty. It drinks a lot of diesel, and it is not environmentally friendly, but it is the most efficient way that we have out in the roadway to get asphalt recycled today, right? So honestly, the biggest expense on our train with our equipment is that mill right there. Pulled behind that, so this will be interlinked too with our pintle hitches, is our crusher pug mill platform. And so the wrap that comes up off that rear conveyor, we get dumped in the screen deck. And so we screen 100% of the wrap that goes into our cold mix. So we ensure we have 100% sizing on our material, right? And that oversized material actually moves it away from the right side of the screen to the left and goes down into that crusher. So we're able to have a secondary crush. We crush that wrap a second time. Not mill heads the first time, second time's with our crusher. It goes through a closed loop conveyor system back up to the screen deck. If it's sized appropriately, down it goes up to the pug mill. If it's not, it goes through the system again until it's crushed down to size, right? We have some projects where honestly, 0 of the wrap runs through the return. It all goes right through the screen deck there. We have some jobs where we measure it, up to 40% of that wrap will have to get crushed a second time to get appropriate sizing. So having that engineered control in line with your train really makes it a lot more efficient and a lot more consistent, repeatable results with that cold mix. So after we've basically crushed that wrap down, that material will get dropped down through the screen deck and then move up to the front of the platform on the right side of the screen here, up to our pug mill. And when it does that, it goes over a weigh bridge. So we weigh every single pound of wrap going into that pug mill. That weigh bridge information is communicated to a centralized computer. That centralized computer knows just how much oil to add. We get that amount of oil we add from a mix design we've done before the project even starts. And so it controls, it's metered, the amount of oil that would go in there based off of weight, which also gives us really repeatable, reliable results with the cold mix that we're producing. It's one of those engineered controls that really helps out a bunch. That material then gets dropped down in a windrow that drops down in between those 2 tandems in the back, and off we go. The last piece of the train is our crusher, or our pup, or oil tanker. We call it a pup. I've asked our office why we call it a pup. I don't know where that started. I'm not sure. No idea. But that's I guess that's what we call it. So basically, that can carry about 6,000 gallons of oil in it, and we're using that through a piping system to get the oil back up to the pug mill to make the cold mix. So if we're doing a foam job, that's just a PG graded binder that we have to heat up to 325 degrees. We do have independent heaters on that pup to heat the oil up to temperature as well on a roadway job. If we're doing emulsion, we don't have to heat anything at all. Everything runs at ambient temperature. So that's a big windrow we have there. So with the cold place recycling process, it starts looking then after that like an HMA job. So we're gonna pick that up with a pickup machine, and then we're gonna paver lay it with a modern paver, right? That paver's got all the bells and whistles with the ski, full electronics on it, and all the things you need with a screed to get the smoothest ride possible out of the process. After that, we need to roll it out. Generally, we start with a double steel drum roller on top of that mat. Remember, that thickness is about 3 to 4 inches. We'll oscillate or vibrate the first pass count back and forth to refusal. With that double steel drum, then we'll hit it with a rubber tire roller, kind of knead that surface back together. And lastly, that same double steel will double back and go over that surface, but not oscillating, just static, right? Not vibrating. And we'll establish a rolling pattern with a construction technician that's out there with a nuke gauge to optimize that density. Anytime through the course of the day, the one thing that's unique about CIR is the material that's in the road is what we have to recycle, right? So if we have a 10-mile long job and it was paved 5 years apart, right halfway through the job, so there's the five-year difference in mix and 5-year difference in materials. Once we go to that transition spot, we'll update our rolling pattern because we now have new materials that we're contending with, right? So if you have a job or a road that has a bunch of different stuff on it, that construction technician is just going to be busy all day doing rolling patterns, right, to ensure that we are getting the optimum amount of density on the job. Here's the train kind of pulled back together. Again, like I mentioned, 2 lane miles a day is generally our goal. We do a full lane width at a time. Some folks wonder, well, how wide can you go? We've gone out as wide as 21 feet in one pass. So we do that. We put a secondary mill out in front of this setup here. Set up kind of a windrow in front of the train, and it picks up all that material at once. I can tell you this, 21 feet's the max. We can't go any wider than that. Also, 21 feet at 3 inches is the max. If we go 4 inches, we wouldn't actually be able to push all that cold mix through the throat of the paver, right? So there's limitations to the process. So honestly, if you had a lane width that was wider than that, or a need wider than that, we would just make a second pass with the train, right? But we can accommodate wider lane widths fairly easily. So what do we add to make the cold mix? Just some details there. If we're going to add an engineered emulsion, that's what state of North Dakota's done mostly. We're going to add about 3% by weight. And I would say most, just a standard emulsion, the folks that use that, those types of people that select that are going away. Most folks are now using an engineered emulsion where they add a chemical package to a standard emulsion to get better density, you get better stabilities, it paves better, and it works out better for you. There's actually a really small investment to kind of move up to an engineered approach, and so that would be something that we prefer. If we're doing foam, we do a lot of that in Iowa. Iowa does a lot of PG-graded binder foam. We'll use basically latitude is what determines the binder grade that we're using, right? Up here in the upper Midwest, we're using like a -34 grade. As we work our way south, the -28, right? If we get down into, we do work in Texas, New Mexico, we'll use like a -22. So match up that binder grade with cracking potential, basically, and make sure those work out well. So the other thing that we're able to do is if you get through your project selection process and you're not getting the stabilities you need or you're looking for, or if you want a higher performant cold mix, you want it to last longer, right? You have a heavier truck traffic route, we can add things to the mix. We can add cement, right? We can add hydrated lime or quicklime. We can add lime slurry if you're having stripping issues to overcome those. We can add things like Ad-Rock as well, right? So there are a lot of levers that we could pull to make the cold mix work best for you. And those things can either be determined before a contract's even let, right? If you work with an engineering firm or the DOT or someone else to figure out ahead of time, or some folks have the contractor develop the mix design, where they have to go through and go through that engineering process, right, and take care of that for the owner. Whichever works best for you is what we can do. Get down to project selection. So what types of jobs does CIR work well on? I would say jobs that are have asphalt pavements that are old, tired, shot, oxidized, with some cracking in it. Those are all great CIR candidates. If you got alligator cracking throughout the road, not going to work real well, but not much does work with alligator cracking, right? You kind of got to start over. Wrong tool, wrong time, wrong place. But this is a job we did just outside of Milwaukee. Maybe you can see there's a ton of transverse cracks on this road. The CIR job we did this is 2014. I drove that last summer. I think it had a crack in it every 190 feet. So really reduced the reflected cracking in the road, even 10 years later. But you can see the longitudinal crack that's in the road is in the middle of the lane. So what does that tell me if I put my engineering hat on is the asphalt's just shot. If we would have seen 2 longitudinal cracks along the wheel path, right, with some rutting and some yielding, then I would say, well, whatever's below there is probably giving way too now. In CIR, you don't want it there. Okay, we can't fix structural issues with CIR, right? We can fix asphalt that's old, tired, and aged out. That's where it works best. And we do CIR, we do it on top, if there's HMA on top of concrete, we'll do that. We've done CIR on 12, 14-inch thick sections of CIR, or sections of HMA. We've done it on 3-inch sections of HMA. We really make it work about anywhere. And if there are variables throughout the length of the job, I think Tom kind of mentioned it, but sometimes we'll apply 1 or 2 or 3 different treatment types to one project to make it work out, right? If those problem issues or locations are kind of localized. So we really do CIR just about anywhere. The depth of CIR, so 3 to 4 inches is the sweet spot, 5 inches is max. We get north of 5 inches, or get less than 3 inches. There have been many studies done, a lot of it coming out of Iowa. They've been doing CIR for 30 years. They probably do about 3 million square yards a year, plus 3.5 million now. So they have a very long history of cold-in-place recycling. Whenever they've tried going with a shallower depth, shallower than 3 inches, they see that resistance to reflective cracking really falls off, right? So we can't do CIR at any depth, right? But those benefits you get out of it don't outweigh the cost, right? So it's the wrong tool, wrong time to do that. So that type of treatment would lend itself to something, it could be a mill and fill, it could be hot in place recycling, it could be something else. There's lots of different, things that are available to you. When you go from 4 to 5 inches, I talked about the size of that windrow, it grows, right? At some point, there's only so much we could pick up and put back down smoothly and with good density, right? So you go north of 5 inches, you probably want to start introducing a pad foot roller to get good uniform density compaction. That really defeats the purpose of paving it, right? Because we have to then blade it back out. So wrong tool, wrong time. You want to go more than 5 inches. But there is no set rule. Like you have to, doing the CIR process, you have to grab a half of the asphalt thickness, the HMA thickness. That's not a rule. Some folks have said that in the past. That's really not the case. We can make it work with any thickness of HMA you leave behind. Quality control. This is an engineered process, right? So like I said, we have a construction technician that's out there in the grade. They're going to help us check our gradations. They're going to monitor our yields, our incorporation rates of our materials. They're going to be doing density testing, basically checking out, make sure that what we're being paid to deliver, we are delivering, right? So if you're an owner, right, that would be something you always want to make sure you have in your specification, right, as a robust, QC testing parameter. Surfacing a cold mix. So this can really depend on the current traffic you have today and your anticipated traffic in the future, right? We've seen lots of different things go on top of cold-in-place recycling. We have seen double chip seals work really well on lower volume county routes, right? Even some city routes. It's a really great option for you. As traffic volumes come up, microsurfacing can work well on top of CIR. Keeping in mind, right, that you're not going to get the only way you get a 25-year design life out of CIR with a double chip seal is if you maintain the chip seal, right? So I don't know, year 8 to 10, you probably got to put another lift on, I suppose. You keep an eye on that, and then maybe years 17 to 19, you got to do another one on top of that to get to your 25. But we've seen it get there in the past. And then as we kind of work our way up the state routes. Had a lot of success with 1 lift of HMA on state routes, and then out in the interstate, we've done it with 2 lifts of HMA. We've even done some airports with it as well. Have done a 4-inch CIR with 6 inches of HMA on airports here in the upper Midwest with some really great successes. So just kind of a case study. So this is a project we did with the North Dakota DOT back in 2021. It's just outside of Hettinger there in the southwest part of the state. It's a great cold-in-place recycling candidate. I know there were some folks I've been talking to today that rode 8 before we did the CIR, Northern Improvement did the HMA. And it was one of those roads where if you had an open cup of coffee there, you'd end up with a burnt lap. It was really bad. The ride quality was very poor on 8 out there. And so here we are out there recycling, beautiful part of North Dakota. Out there we had so that's the 4 pieces, right? Talked about being interconnected there with panel hitches of our train. Out in the front there, we had a little mill out front because we actually were recycling 14-foot lane width at a time. So we had a little windrow out in front. And we also had a little bit of cement powder to this job per the mix design. So here's some project details, right? The job was about almost 25 miles long. Mostly 3-inch CIR with some 4-inch CIR. We ended up using an engineered emulsion, and so that designation was a PGXX minus 28 when the DOT let it. So that'd be what, as a contractor, we're looking for that oil type if you're looking for engineered here in North Dakota. We added a 0.5% cement, and In total, we recycled over 68,000 tons of that old HMA that the state owned, right? We repurposed that for the state. And it was overlaid with 3 inches of super pave. And I've been out in that road several times since, and it's still riding really well. I know talking to Steph I see Steph back there. I think it's pretty cool. There's a TSD. So that's a traffic speed deflectometer, right? Cool. I think they're going to test that this upcoming year. Basically, it's a falling weight deflectometer that can drive at speed at like 50 miles an hour. So they're going to run that down, hopefully this section of North Dakota 8 this year, and get some feedback on how that road's living its life, right? How strong is it still? I'm really excited to see what those results are out there. That and that TSD thing sounds really cool. So I'm a bit of an asphalt recycling nerd, so bear with me here. So pricing for the process, right? Folks interested in this, it was about a little under $80,000 per center lane mile. It's a width of 28 feet, right? If we were recycling a 24-foot width, that'd be about $67,000 per mile, right? So we talked about right tool, right time, right place. This might not be in your budget, right? If that's the case, this is not the solution for you, right? It's probably a little more long-term fix. Look at life cycle cost analysis, right? But you break that down at a ton price of cold mix, it was, just shy of $29 a ton. I'm not really sure what you guys are paying for hot mix by the ton here today, right? But in this type of application, keep in mind you have to surface it with something. So this is not a finished product. So you have to have that surfacing cost to it. But if you're looking to budget, those numbers there are good numbers to have. And then as a contractor, we always really boil everything down into square yardage price, right? So that 466 means a lot more to me than it probably does anybody else here. But that's the number that we always keep an eye on. And then a unique thing that we've been working on with CIR, because we are recycling asphalt, is that we're creating carbon credits with that selection to go from an HMA structural design to a CIR structural design. And what we're able to do is, through a series of following an ISO standard, looking at our fuel consumption, and then working through Vera's marketplace, we've created carbon credits that we've now sold on the market. So actually the credits that we produced off that ND8 job got sold to BMW last fall. They wanted to buy them. So if you are the state or the county and you guys want to make your own carbon credits and sell them, give me a call. I'll tell you how to do it. Pretty slick. All you need is some fuel consumption data, some production data, what type of equipment you got in the job, and you're ready to go. So on North Dakota 8, if you're to just look at our CO2 savings, baseline design, if it would have been similar structurally, right, HMA to CIR, would have produced about 4,300 tons of CO2. Through the CIR process, though, we only produced about 1,400 tons, right? So a significant reduction. So on that job, we reduced emissions by over 2/3. Barely over 2/3, but over 2/3. And what does that equate to, that 2,800 tons? It's 7,306,054 miles driven by a passenger car. The EPA actually has a website where you can actually put in the tons and kind of convert it to other things so the numbers make sense to you. I think I definitely encourage you to do that. These are metric tons, by the way. Just kind of wrapping up here, if you guys are looking for additional information on cold-in-place recycling, one of the best resources is to go to roadresource.org. This is put out by the Asphalt Recycling and Reclaiming Association. It's free to use. There are over 500 individual pages within that website of information on how to recycle asphalt and also how to do pavement preservation. It's a really great tool, and it's free. It is awesome. A lot of time went into it by the industry to put it together. So I definitely encourage you to go there. If you want a book to put on your desk at the office, the basic asphalt recycling manual, we still have some of those at our office. Get a hold of me, I can put it in the mail to you. That'll talk about all the things I talked about today. It also covers hot in place recycling, soil stabilization, reclamation, milling. Basically, any way you can recycle asphalt is covered in that BARM. And then I guess lastly, I got some time for questions maybe, but that's a picture of Minnesota County Engineers Association from 1975. My grandpa's in the front row there, so I'm a third-generation civil engineer, so I always like sharing that picture. But don't know if there are any questions. I can take them. Do we have some time?
Yeah, we got some time. Any questions out there?
North Dakota for the DOT. And I have a question regarding, I've got a roundabout in the city. I want
Okay.
to know how far ahead should I start the cold in place, like from an intersection?
Right, so the first question here was about a roundabout and how far away from it should you stay
Yeah, with the cold in place.
with the cold in place recycling. So if you're coming up, so here's what happens with that cold mix. After it's been surfaced with something and it's cured out, you got no issues. But there's this time when it's tender. So if that roundabout is going to remain an active intersection, right, you do not want to have traffic stopped on that cold mix mat, right? So just like hot mix, when hot mix is cooling down, if you got a truck sit on a mat that's not cooled, it'll just dimple if it's sitting there, right? Same thing happens with cold mix if you don't have that material out of there. So honestly, what I would say is you probably want to hold that back, whatever the potential backup queue is at that roundabout, which could vary a bunch, right? But I would say a minimum 300 feet. And if there's a chance for that queue to be really long, if it's, harvest time and there's just a bunch of people trying to get through an intersection and it backs up a bunch, and you either want to, contractually not do the work at that time, right? Work around that or do something else, but however long that queue is. Yep.
Is there a time frame to get it covered?
So the question is there a time frame to get it covered? I wouldn't say there's a time frame, but what needs to happen before you cover it is so the water that we add in needs to come out. That completes the curing process. If you don't, you can trap that water in there.
What does rain do to it?
Rain, as long as it's been rolled out and we get traffic rolling on it, won't affect it at all. What you don't want is if we're in the middle of the train going down the road to have a downpour come, because that makes a big mess and that's a big no-no, right? The only way to fix that is to generally have to recut it. We probably have to add some lime or something to dry it out. It's not the best thing. Best thing to do is avoid rain during construction. But honestly, most folks, if they're putting HMA on top, they'll see that material cure out anywhere from 3 to 7 days afterwards. Then you can surface it with something. A lot of that depends on temperature, time of year, amount of wind, sun it's getting, stuff like that. So that is, one of the limitations, right? You can't just, there's a kind of sensitive time in there, right? And so right tool, right time, right place. There are some, I only had 25 minutes today, right? So, but there are some limitations. I'd love to talk to anybody about any of those things anytime. We just want to make sure that CIR is being used on the right road, the right time, the right place.